All right, so let's get started. Still just getting everything set up a little bit here. Cool. So let's jump into this Learn module on Args and KW Args. So this is a little bit of an advanced usage of parameters and arguments in functions in Python. So star args and kwargs, as they're sometimes called, args and kwargs, are kind of special ways of naming functions, and they allow us to do some kind of cool things. So let's start off with star args. Oops. So well, we've got a good example here. Certainly by now most of you are probably familiar with, if you know you're with us at this point in the material, you're probably familiar with the print function, certainly, and you're probably familiar that the print function can take any number of arguments, right? So if I do this, right, I can just keep passing argument after argument to the print function, and we can actually build functions that have this capacity with star args, and that's how I'm certain that's how print is built under the hood at some point. Excuse me. So let's see. If we do, let's think of a function. Let's write a function that takes in any amount of numbers and returns each number. Like, we'll just do like a rolling product. So we'll just return each number multiplied by every other number. So this is basically kind of a factorial function. So I want this function to take in an unknown number of arguments. So I'm going to say star args. And for now, I'm just going to pass, and we'll write a little test for this before we start. Print. Print rolling product. And here's where here's kind of the funny part, right? So I could write a function that takes in like num list, and then I could just pass it a list of numbers, right? But this, if I do star args, I can just pass it. I don't have to pass it a list. I can just pass it however many numbers I want. We'll do star args. Like this. So if I say prod equals 1 for I in args, prod times gets I, return prod. There we go. So 4 times 3 times 6 is 72. That's what we get. So this is basically a factorial, but instead of taking in a range, we take in some some arguments, just some unknown number of arguments. And this, to be clear, this will allow me to pass any number of arguments that I want. So that can be a really useful thing. There's some cool things that you can do with this, right? So let's say I should think of a really good, I should put together like a presentation for this, because occasionally in like my own coding, like I'll think of really cool things to do for this, but when I, for some reason when I stream, I'm just like drawing a blank, like what was I doing with this? So I'm gonna kind of just stretch this example here, unfortunately. But let's say I wanted to like add a message to this for whatever reason. I don't know. So I could have a positional argument that I name, and the first argument will just be returned as is, right? So if we look at this, I'll make this clear, right? So we'll get 2 times 6, which is 12, and then this first argument is actually just going to be the product is, right? And it'll just return that string, and then the arguments, right? So when I just name a regular parameter like this, I just create a regular parameter. This is a regular positional parameter, and so basically it's going to eat up whatever the first argument passed is. And then args is going to eat up all the other arguments. It's going to eat up all the other arguments passed, right? So there's something cool that you can do with star args like this. You can specify other arguments if they're defaulted after star args, and it allows you to do something kind of cool. So let's say let's do something like this. We'll name an argument, we'll call it type, and I'll just do something like this. It'll take a string, and this will be the type that this returns. Since this is returning together multiple things, we could have it return as some collection type, right? So here I can do if type equals list, then we can return this. Yeah, we'll return it as a list. lf type equals tuple. We'll return it as a tuple. And then we can do lf type equals, let's say, set. We'll return this as a set. And then maybe we could do dict. And then we could just return it. Let's just make the first one the key and the second one the value, like that. So we have a few options here. Or I guess I can do the full, is it 1p? It is. I'll do the full name here because it kind of makes more sense. And I think we'll actually just default this to tuple. Okay, cool. So if I, of course, single equals, that's got to be double equals. Cool. so if I run this like this, right? So this argument has a default, and kind of the cool thing about this is everything that comes after star args, I can't access just by passing arguments positionally, right? So we can pass arguments in two ways. We can pass arguments as positional arguments, which is what we're doing here, and we can pass arguments as keyword arguments. So that has to do with when we're passing in arguments, when we're calling the functions. Let me clarify that and sort of let's kind of write this down and canonize it a little bit, right? So two ways to pass args. One is positional, and the other is keyword. So what we're looking at here is positional. And the only way to access everything after the args, since basically star args just swallows every positional argument after that point, right? So message has to swallow the first argument, and then star args takes on all the rest of the positional arguments, right? So what that means is that when I declare a new parameter, it has to be defaulted to something, right? Because I can't have, the rule is you can never have a parameter in the function that doesn't have a value at the time that the function is called, right? So I guess you could say there's sort of, there's we can give each parameter a value by either passing positional arguments or keyword arguments, or by defaulting it, right, in the definition. So if it has a default, it'll just assume that default. So the nice thing about this is this defaulted argument sort of acts as a configuration that I can't like accidentally overwrite, basically. So I can only access this by way of keyword argument. And this is kind of cool because let's say, I want to use this function to like display a message and the product of whatever args that I pass. And I know, 9 times out of 10 or whatever, I want to use this function. I want to get a tuple back. So I'll just leave it default. Oh gosh, there's 2 QPPLE. Oh gosh, I'm having a dyslexic moment with how to spell tuple. Wait, I know how to do this. There we go. It is 1P. Sorry. I'm just doubting myself. Okay. Cool. Yeah. So the if I'm certain that 9 times out of 10 I want this certain kind of configuration to be true for this function, I can just set this and kind of forget about it. But like maybe every now and again I want it to give me back a dictionary. So I can say type, and I'll name a keyword argument like this. So we'll pass this argument by keyword. So we'll say type equals tuple, or excuse me, dict. There we go. And then notice it's going to give me this back as a dictionary. It kind of got a lot of colons in there because I left out like that. But yeah. So that's a way that I could use star args to sort of protect this configuration information. And a lot of times you end up using star args to do for only this purpose, right? this is playing multiple roles here, and they're multiple roles that may or may not go together, right? It's not unheard of to see something like this, right? In this case, I kind of lose args. Let's see. Yeah, we'll just have to. I'm just totally butchering any functionality or practicality in this function, but let's see. The 3 were given. Yeah. So in this case, right, this function takes one positional argument and one keyword argument, and I can't accidentally I can't accidentally override that keyword argument with a positional argument, which is kind of nice. Like I can't just I can't misuse this function in a way. In order to give this second argument, I have to say type equals dict, right? Like I have to do this. So this is kind of cool. This is kind of a cool thing for maybe there's a feature that is potentially dangerous in certain circumstances. Maybe dangerous in that it could be very inefficient. Maybe dangerous in that it could crash your program, or cause some other kind of undesirable behavior or unpredictable behavior. So quote unquote dangerous, for a function, right? So maybe there's some configuration information that you want to assume for most of the time, or just you want to enforce that, okay, when the user of this function, when the programmer, yourself or whoever's going to use this function, is going to pass a value for this argument, you want to enforce that they have to use a keyword argument like this. That can help make it clearer what that argument does. It can kind of help say, like, okay, yes, I intend to override the type in this particular case, or I intend to pass a value for this particular parameter, right? So it can enforce using a keyword argument when you call the function, which at certain times can be desirable. Like I said, like if you want to make sure that whoever's using it is careful and that they know that they know what information is being passed to what parameter, basically. So this just enforces that. So yeah. And I think it'll even work. Yeah, it'll even work like that. So in this case, we don't even have to default it, but this just means that this second argument absolutely has to be a keyword argument. There's no, and that when we call this function, we have to have that keyword argument. And in fact, I have heard of this. I heard somebody give a talk about this a long time ago, where they were talking about some coding style that they were using in Python that they were enforcing in their work, and they were writing all their functions with star args in the beginning and invoking all their functions with keyword arguments like this. And I haven't employed that style in my own coding, like as a rule, but it's a really interesting idea, and people are out there doing it. Somebody's out there doing it, or at least they were. So that is a stylistic choice you could make. You could start all your functions, or you could start some functions, with a star like this, and then when you go to call them, then you have to use the supplied keywords like this. So I have to, when I supply message, I have to say message. When I supply type, I have to say type, right? And then potentially the benefit for this is we could do this in either order. I don't know. I don't really know what. That's not really actually a benefit. I mean, but it's kind of a neat coding style, and it's kind of a neat. It makes using this function sort of. It makes calling it and utilizing it kind of have a different feel to it, and it gives it sort of a utility of like needing to be explicit, and that explicitness makes how you're using it sort of more clear. And in a lot of cases, we can just get away with positional arguments, and that's fine, and it's perfectly clear. That's how most programming in most languages is done, and in Python, and generally that's fine for most people. But this can be a good tool to add to your arsenal to make your code more clear and to make it easier to work with, right? So those are some different ways, and I know I apologize because this is this kind of a just a toy function. It doesn't really do anything that meaningful, but it just needed a medium to kind of play around with star args. So yeah. So I know I've talked about, so it's kind of funny because this lesson is about star args and KW args. KW stands for keyword arguments. I've been talking about keyword arguments. KW args are a little different than what I've been talking about. They're similar but a little different, right? So there's this way of calling your function with either positional arguments or keyword arguments, right? And if I didn't want to enforce keywords, I could just take out the star and we could do message and type, right? And we could either pass these positionally. It's up to us at this point. You can always pass a positional argument as a keyword argument if you want, and you can do them out of order. But I think if you start with, if I start with type equals dict here, I can't do MSG, I can't do message as a positional. So if you start with, there's a special error just for this specific case, which is positional argument follows keyword argument. So it's kind of weird, right? We always have the option to pass a positional argument as a keyword argument, but if we do that, we can't pass any positional arguments after. And this is what I'm referring to when we call the function specifically. So that's what this error is saying, right? If I try to pass a keyword and follow that keyword with a positional, then we get a problem. A problem tailor-made to this specific solution, which is kind of interesting. Oops. Restart that. Cool. The reason for this is, it might be obvious what the behavior should be. I mean, you could argue that, well, if you passed this second one by keyword, then the one that's left over is the one that should just swallow the positional argument being passed. This is clear with two arguments, kind of, right? But it's already kind of why pass type? I could see, even with two arguments, I could see if this were possible, I know people would do it, and it'd be annoying. It'd be it would be the kind of thing you would look at, you might ask, why is that not possible now? But if you think about it, if it was possible, and I encountered somebody's code that was like that, they wrote a function that takes in A and B, and then passed in B as a keyword argument, followed by A as a positional argument, you'd look at that and you'd be like, why is this allowed? This is dumb. This should be an error. It would be one of those things where you'd look at it and you'd be like, this is annoying. Even for two arguments, when it's fairly easy to figure out, things can get much more convoluted much more quickly, let's do, I'm going to kind of just go off the rails here. Let's just do A, B, and C. So let's say, yeah, let's just return A, B, and C. We'll just return it like this, right? Because we're really just looking at the arguments right now. So if I said let's say B as a keyword argument, and then we'll just pass two kind of random strings. Right, now there really kind of isn't an obvious solution, right? Does foo get passed to the thing after B, or does it get passed to the first available positional argument, which is A, right? So this would be, I think the most reasonable solution to this would be we'd be passing B, then A, then C, which is confusing, right? Like if this is allowed with positional arguments like this, it would be confusing. So if you did want to pass them in that order, fortunately Python would let you. I'm not sure why you would, but hey, I guess it's your code, right? So we could do B equals hello, A equals foo, and C equals bar, like this. So you could pass them out of order, but the nice thing about enforcing that, you know, if you want to pass them in a different order for whatever reason, you have to do it in keyword arguments, means that you're clear. It's very clear that, you know, this is going to be the value for B, this is going to be the value for A, and this is going to be the value for C, right? So if I run this, we get foo, hello, and bar. So that's going to be much clearer, right? So this is kind of funny because like we talk about these as being keyword arguments, and then when we talk about Kwrs, it's like I said, it's kind of related to this, but there's sort of a different facet in addition to this. So let's look at that too. Let's see if there's actually a good problem in here where I can give a good example. Okay, so let's just do this. This is actually a pretty good example. So let's do this. Let's make a Args function. So we'll say def. I'll just use the example they had there. Human will take in Args. Now when I want to do Args, I do star, and then before I meant to mention this. When I was doing star args, I did star args. We can call this whatever we want. You could call this anything. By convention, you call it args. When you do star args, you just call it args. Same thing with kw args. If we want to have a kw args parameter, we have to do star and then kw args. Well, excuse me. We have to do star and then whatever name of name of parameter, but by convention we do Kwrs. So we'll say for k v in Kwargs dot items. So Kwargs, it's kind of funny. Kwargs is a dictionary. When you do something like this, it's just going to be a dictionary. And then we'll say print k v and I'll do something like that. Okay. Name. So in order to pass in KWArgs, so this basically allows us, like Args did with positional arguments. Excuse me. Okay, let me start that over. Let me start that sentence over. I'll try to use English this time. Using args allows us to pass some unknown number. Star args allows us to pass some unknown number of positional arguments. Using KW args allows us to pass an unknown number of keyword arguments, right? So we can still pass positional arguments without star args. We just can't pass an unknown number of them. We can still pass keyword arguments without star args or KW args. We just can't pass an unknown number of them, right? We can kind of use star args to state to Python that this function takes no positional arguments and must take a finite number of specified keyword arguments, as I showed before. And we can, if we want to make a function that takes an unknown number of keyword arguments, we can use star Kwargs, or just Kwargs. We don't call it star Kwargs, we just call it Kwargs. Okay, so we'll say name equals I'll just Clark, and let's see, hat equals cool. Oh god. Let's say job equals DSI prep teacher. Okay. Okay. And where did I go wrong? Expression cannot contain. Oh yeah. So that's the funny thing, because I think about Kwargs as a dictionary. So I'm like, I'll make the keys strings because it's a dictionary, and it is. So if we look at this, we can try this another way. Let's just print Kwargs. So you can see that returns a dictionary, and where I had these look like variable names, you know, and the way they are written in Python is like a variable name, in that there's no quotes around it, it's not a string. But then, excuse me, when I get into the function, those identifier names, those identifiers get turned into strings, which is kind of a weird conversion. You just have to know that happens. It's weird in that it's like that that kind of thing is kind of atypical for how Python generally does things. Like things don't just change from being an identifier name into a string literal, except in this scenario. And you just have to remember that they do. So you have to, just keep that in the back of your mind. And just to further prove that this returns a dictionary, we can print the type like that. Cool. All right. Cool. So I just want to do a quick reminder for folks. If you've got any Python questions, feel free to just post those in the thread, and I'll be happy to go through them. Okay, cool. So let's just jump into here and start doing the challenges. So what will the following function call print to the console? So we have sort, remove, dupes, print. Okay. It's a heck of a name for a function. It'll take in *args. So this means it takes in an unknown number of an arbitrary number of positional arguments. Sorted and unique will be a set of sorted args. That's kind of interesting to make it a set after sorting it, because that could unsort it. And then here we're just going to print this substring, and we're going to join all the elements as strings. We're going to map the string function to each element in the list with map, pass that collection to join, and then join on all of those. So I'm not going to pick through here and find whichever ones. I don't know if there's like any. I assume there's definitely some numbers that are going to be missing, so I'm just going to run this. 1, 2, 3, 4, 5, 6, 12, 45, 56, and 120. Cool. Correct. And this is one of those weird things, like we talk about sets being unordered, so it's kind of, like I said, this kind of makes more sense to me to do it this way, because we'll make it a set which will remove the duplicates, and then we'll sort it, right? In my experience, sets will retain an order. They happen to retain an order if you have a set of numbers, but if you have a set of, I think, strings or tuples, I think the order will come out differently every time. So, if you're writing code like this, and I might go in and make an addendum to this and swap that around just so it's clearer, because I think that's sort of a curveball that doesn't need to be there or wasn't intended to be there. So, cool. So write a function called, let's just do this. Oops. Write a function called sumArgs. This function takes any number of numbers as arguments. So any number of numbers as arguments. We'll call that star args, and returns their sum. Well, this is basically the function that I wrote initially, right? Except I'm just summing them. So I can just return. So I forgot to mention this. Let's just, well, here, let me do this. I'll return args, and then I'll print the function. We'll do a little test here. So I mentioned that kwargs evaluates as a dictionary. Star args evaluates as a tuple. So let's just look at that. So if I do, well, we'll just start with 1, right? So even if I give it one number, it's going to be a tuple containing that number, and that's a single element tuple. Okay. So if we do all of these together, it's still going to be a tuple. You know, of course, just to prove what I'm saying, we'll print out the type, and we can see that that's a class tuple as well. So the cool thing is we can just use the sum function, and that'll just sum our arguments like that. That'll give us 45. Cool. Sorry, I was just checking on something there. Making sure the streaming quality was alright, just looking at it on YouTube really quick. I like to just pop in and check in, make sure the fidelity's alright and the audio's okay. Cool, so that's correct. That'll work like that. Obviously we could do this, well, perhaps not obviously, but to me it's obvious. We could also do this as an accumulator pattern. We could say accumulator equals 0 for num in args, acc plus equals num, and then we'll return acc. We'll get 45. We can do it like this. I think the sum way, the first way is probably preferable, is just so obvious and easy. But I always like to show accumulator pattern solutions because I want people to get in the habit of thinking about like how to solve problems with accumulators, because they're so widely applicable. Like I've never been able to oversell the utility of getting good at accumulators. And like what you'll find, and what I continue to find, is that problems that I solve, there's problems that as I've progressed as a programmer, there's problems that I would always solve with an accumulator that at some point I'll find that there's a different way to do. Maybe there's a closed formula that's more efficient. Generally, closed formulas are preferable if you know them, if they exist and you know them. Or there's a built-in tool that just does it, that maybe uses an accumulator under the hood or whatever, but just makes it easier, right? So I used to do this thing with like string formatting. I would build these, like if I was formatting a string with numbers in it, I would build this, on a number of occasions I built this, like I would build a function to like put in zeros on the left-hand side of a number, and it's an accumulator pattern to do that, to kind of format it to the correct width and with the right amount of padding and whatever, just positioning it however you want, using whatever symbols. And then actually just a couple months ago, I found out there's a string method built in called zfill. Z is in 0, so it takes in a number as a width and does exactly what I was doing, what I had done a number of times manually with an accumulator pattern. So that's why I like to, even if there's an obvious way of doing something, or even if there's another way of doing something, I like to kind of emphasize the accumulator pattern approach, because it's great. It's worth getting good at the accumulator pattern in all its different incarnations, and being able to put that together quickly and easily, because it'll fill in the gaps of what you don't know yet, right? All the little tips and tricks and little things that you haven't picked up yet, you can fill those in if you're good at the accumulator pattern. So that's why I'm doing that. Excuse me. Okay. All right, so let's just copy paste this in. Oh, apologies. All right, so write a function called sep and sort, which takes any number of unnamed parameters. Unnamed parameters is just positional arguments, right? And they're kind of trying to drop that hint. They're like unnamed parameters, which just means positional arguments. I'll put these bullets back. Oops, like that. Okay. So this function will take any number of integers and floating point numbers. It should go through all of the items that were passed, separate them by type, and then sort each collection. Ooh, interesting. So let's say this function will take any number of integers, floating point numbers. Okay, so just ints and floats, it looks like. So let's start with this def sep and sort, and we'll take in star args. We're not going to use Kwrs because they're unknown number of arguments, or of unnamed arguments, right? So let's just pass for now, and let's do something like print sep and sort. We'll take in 4, 3.3, 7, 0.9, 1.8, 3. Okay. So this should, I'm not sure how it wants it returned. I'm kind of guessing it wants a tuple of lists, or maybe here's an example. It looks like it's showing us a list of lists. Yeah. That's interesting. So this is an interesting test, because we only have integers, and we only have a list for integers. We cut this out, and we'll put this here. Oops. Okay. And then with this one, we should expect a list of, I'll do integers first, so that'll be 3, 4, and 7. And then the floats will be 0.9. That needs to go in a list. 0.9, 3.3, and 1.8. Okay, cool. So return the value. The return value should be a list of lists where the first nested list is for integers, okay, and the second is for the floating point numbers. If no values of a specific type are passed, do not return an empty list for that type. Remove it altogether. Okay, cool. So let's even do another test, and I think what this wants, if I do true hello, let's do a list of whatever. In this case, we should get an empty list since we don't have any numbers. The list here does have numbers, but it itself is not a list, it's a number. Or I mean, it's not a number, it's a list. Okay, cool. So I'm going to declare a list to return like this, and we'll return the list. And I'll just say for num in args, and we'll just test the type. If type num equals list. What am I doing? If type num equals int, and then we'll have an elif type num is float. We'll pass for now. So if the type of the num is an int, interesting. You know what? We do need to establish our targets. So this list should have 2 sublists in it. So what I'm going to do is I'm going to say if type num equals int, we're going to say list sub 0. So list sub 0 is the first nested list. That's our int list. That's going to be dot append num. Otherwise, list sub 1 append num. Okay, cool. So let's just try this out. Not going to be quite done yet. Oops. Did I? I did a period instead of a comma there. And there as well. Pritten is not a function, but print is. There we go. Okay, cool. So we got the right result for the first one, but this right. Interesting. Okay. So we're not quite done here. Let's call this list 1. I'm actually going to call it list A, and we're going to have a list B that we're actually going to return. List B equals just an empty list, and we're going to say for list in list A, if len list, so list, just LST, is the nested list in list A, and I'm going to say if the length of the nested list, why don't I be clear about this? Nested list, if the length of the nested list is greater than 0, then we will list B dot append sorted list nested list. Whew, okay. Cool. So that'll solve both of our problems. That will solve the duplication. So if the length is equal to 0, it's just not going to append it onto list B. And if it's greater than 0, then it will append it and sort it before it appends. Cool, and this saves us from having to do any removes. So yeah, that should do it, I believe. Let's test it out, and I'll show a remove solution as well. Okay, so this is a pure, let's call it positive accumulation process, and I say that because we only have appends. We don't have any like removes or deletes or pops or anything. So we could do this without making a second list, I think. So I think what I want to do is we'll just say we'll go through the list and we'll say if the length of the nested list is equal to 0, then I guess we want to, we're going to want to remove nested list. Oh, how would I do this? Yeah, okay. So, new plan from the top. Okay, so for I in range, so I want to do a range. I want to loop through a range of the count of empty lists, which is going to be 0, 1, or 2. If it's 0, it's just not going to do anything. If it's 1, it'll remove 1. If it's 2, it'll remove 2. So let's just call this list. We'll go back to that being list, and then I'll say for I in range list dot count empty list. So there's either 0, 1, or 2 empty lists, and count will reflect that, and we'll make a range to just go through that. And now I'll do list dot remove empty list, and then I'll say list dot sort sub 0 sort and sub 1 dot sort, and that should also work. Whew. And just to be clear, I should have tested this first. I think I have to do it that way. List dot remove. Okay, yeah. We could maybe say if empty list and list, then remove Yeah, so that'll do it for 1, but it won't do it for 2. So we need to do it. We need to do it dynamically like that. Okay, so that's just an alternate version. It might be slightly more memory efficient. Let's see if it works. It does. Okay, cool. Yeah. It might be slightly more memory efficient, but I think it's kind of a I think the first version is a little more elegant to me. But let's see here. Yeah, I think this would be slightly more memory efficient since we're not duplicating the other list, but won't end up being that much duplication anyways. Cool. And then let's see what they wound up with here. We have our initialized targets, which are our 2 empty lists inside of a list, and then our result list. So that's interesting that this is, I think what they're going to do is what I called list A and list B. I imagine that's where they're going with this. Yeah, so for the element in Args, and then this is instance is a replacement for type equals. There's some weird and kind of like difficult to remember kind of special behaviors with instance in certain circumstances. So I prefer to use the type function, and then just check equality. But isInstance will, I think it'll be like if you do type of an int equals a bool, that'll be false, but I think isInstance of an int and a bool will be true. Something like that. I can't remember. It's kind of a weird thing to just have to remember when using isInstance. So if you see isInstance, just know it's a replacement for what I'm doing with type equals on lines 71 and 73. It's essentially the same thing. It's just has different behavior in certain circumstances that I find to be annoying. Personally, I'm just like, why does this need to exist? Oops. Cool. And then this is the same, just appending the appropriate element to the appropriate place, and this looks to be sort of a hybrid of what I had before. Yeah, so if list just makes sure that the list is not empty. So if the list is not empty, then we sort it and append it into the result and return it. So indeed, separated lists is what I was calling list A, and result is list B, what I was calling list B. Cool. All right, on to importing. All right. Cool. Hopefully everybody's doing good. I'm not seeing any questions still at the moment. Yeah, feel free to put them in there if you've got them. If you've got questions from Learn, or if you've got questions about the material I'm going through, feel free to put them in there, and I'll be happy to go through them. So by the end of this unit, you'll be able to understand what is meant by the terms library and module, import functions from math, random, and collections modules, import specific functions from modules in general. So this is a big part. A lot of what we talk about, especially what I specifically tend to focus on, is like what's in the core of the language, but that's really just where programming starts. It really starts taking off, and like when you really get into things, you're importing modules from the standard library, or downloading and installing other modules maybe from open source projects or from other projects, whatever, from wherever you're getting them. And those other modules might be like, they might be, oh gosh, they could be anything. They could be web APIs, they could be special data structures for certain specific tasks, they could be like a synthesizer interface, so you could make program your own like audio synthesizer, or they could be like a game library, or just any number of things, right? So yeah, modules are important. They unlock the whole rest of your computer, and mostly what we've been talking about to this point is just like, well, how do you use the basic features of Python so you can kind of learn to put together problems or put together solutions to problems, I guess, and then use that like when you're actually working with other modules and stuff. So I'll skip the overview. Oops. Well, there goes my 4.0. All right. By the end of this lesson, you'll be able to explain the differences between libraries and modules. Okay. So a module in Python is a file that is meant to be imported. They define one or more variables, functions, and or classes that can be reused in other scripts. Modules can be self-defined, so you can define your own modules. I'm actually doing that here. Or you can use Python's built-in modules. Modules can be accessed using the import keyword. Importing a module will run all of the code in the modules file. So it's actually what I'm using this last feature in my environment that I usually set up here, right? So this is, if we look at the way I have this set up, I have my environment set up with this program Nodemon. So this is actually a tool from JavaScript that I picked up, that I learned about when I was a JavaScript programmer, and it's essentially what it is it's a file watcher. So -w is for watch. So this command reads nodemon watch dot, meaning watch everything, watch every file in the current directory. -x means execute this command anytime one of those files changes. So anytime a file changes, it will run the command ipython3 main.py. It'll execute this file with that command. So I'm using ipython3 main.py to execute main.py, and this is the file that's actually being executed. So the reason it knows when a file changes is basically just when I save a file. So every time I want to run my code, I'll just print hello. I'll just save my file. Oh, I have to actually execute the program. Okay, I'll save my file, and then it'll rerun. It sees that there was a file change made, and then it reissues that command and reruns main.py. So if we look at main.py, there's not much in here. I just have a main function with almost nothing in it, and then this if dunder name equals dunder main, print 20 new lines, and then execute the main function. So all this does is, if this is the file being targeted by the interpreter, which ipython3 main.py, right? So this is the interpreter, and it's targeting that file. So this just says, if this is the file being targeted by the interpreter, then execute the main function. So that's all that means. But all that aside, what I really want to point at here, and what's relevant to this lesson, is this import, right? So I'm not even working out of this file. I'm working out of lib right here. And the reason I do things this way is maybe I want to like jump to another file or like run multiple files together. Well, I'll just execute. I'll bring everything together in main.py, and then I just work out of the other files, like whichever file for whatever specific task that I'm working on. And in general, like I just work out of this lib.py file, and that's just the workflow that I have because that's what I do. But for streaming and just sort of general kind of futzing around or whatever. Yeah, so what's happening here when I import lib.py here, the way I do that is just say import lib, since this file right here is in the same directory as lib, and since it's a py file, I don't need to say like, home slash my username slash projects, right? I don't have to give it the path since they're in the same directory. It's just lib like that. And since it's a py file, I don't need to say .py. It's going to automatically assume unless I specify something else that it's a Python file. So import lib, and that'll just import this file. And on the moment that I import this, this file, it will run all the code in this file. Now I got everything commented out in a string up here except for this part that I'm actually demonstrating, right? Right, so whenever I save this document, it runs this file, imports lib, and executes all the code in there. So that's kind of a neat thing. And it's something, it's something that I'm leveraging here, but I think, given that like my setup is set up by and large for like this directory is set up for presenting from. So either I'm working with a student or I'm streaming or I'm teaching class, and I have a different directory that I teach premium prep out of, but it's set up somewhat similarly to this. So that's kind of for me, that's a useful feature for like presenting, and it might be something that you want to do. You might have some code you want to run when your library is being imported, right? Maybe your library does some sort of like HTTP call, and you need to grab a URL. You need to establish some URL for what those HTTP calls in your library are going to be, right? Maybe you want to do that to initialize the library or something. But in general, other than what I'm doing here where I'm actually utilizing this, I would say in general, this could become an annoying thing, right? Like you might think, okay, I've got my library full of the code that that I want to import, and it's got some code that's going to run in it. But if I import it, it'll just make those functions available. It doesn't just make the functions available; it runs that code. And that's something that's worth remembering, because if you don't know that, and you're looking, you import your own library and it's executing that code in there, it can be really confusing as to why that's happening. You can just make it look like you're just having random unpredictable behavior if you don't know that feature exists. So yeah, just very much worth remembering that when you import, it doesn't just like make whatever functions and variables in that file available. It runs the code. So okay. Cool. So that's what a module is. A library is essentially a collection of modules. So for example, the Python standard library is a library of modules. It's a collection of modules that are that are distributed with a Python installation. Some other important libraries are matplotlib, pandas, and NumPy. So these are libraries that are not part of the standard library. The standard library is, this is a term that you'll hear about a lot of different languages. The standard library comes with the language, right? So there's a number of things that are included without having to import anything. Some languages call that the prelude. I haven't heard it called that in Python. I haven't heard it given a name in Python. But the tools that are included without needing to import, that are built into the language, and you don't need to import, we can call those part of the prelude. Those are just a given. They're always available. So, for example, print, right? I don't need to import something that gives me print. It's just always there. So that's in the prelude. Square root is part of math. So if I say import math, I can do res equals math dot square root of 16, which should be 4. So I can bring in the square root function through the math module. So the math module is part of the standard library. So any Python installation that you work on, you can assume that the math module is there. You just need to import it first before you use the tools from it. So it's not part of the prelude. It is part of the standard library. Okay, cool. This is probably just going to ask me, in your own words, what's the difference between a module, between modules and libraries? Let's say libraries are greater than modules are greater than functions, constants, and classes, right? So your libraries contain modules, your modules contain functions, constants, and classes. I guess they could contain variables too, but everything in Python is, there are no formal constants to my knowledge, so unfortunately. Wait, is there? Am I wrong about this? Yeah. Yeah. There are no consts. Okay. So let's see. Library versus module challenge. Modules are user-defined Python files, maybe functions in Python, programs that can be used in other programs. That's not bad. Python files that define one or more variables, functions, or classes that can be reused in other scripts. That one. Submit this one. All right. Write this. I'll do that. Libraries are, let's see, a collection of modules that all share a common name. That doesn't make sense. Python files that define one or more variables. No, that's a module. Essentially the same thing as modules, not quite. A single Python file that gets distributed with a Python installation. I guess it's, I don't know, this one? That share a common name. Oh, well, I guess that makes sense. Like they have a common they're all a member of a common library which has a name. Cool. All right, the math module. All right, I'm thinking this is actually a good place to wrap up. This is close to our normal stopping time, and we could really dig into the math module. There's a lot that we can glean out of this. So I want to give each of the modules kind of plenty of time to get into on their own. So yeah, feel free to DM me. Let me know how the stream went. Let me know if you liked it, or if there's some things that we could improve. I'm always open to suggestion and feedback. Let me know how the audio is, how the streaming quality is. I'm trying to get the latency and the buffering and the whole thing balanced with a good resolution and good audio. So I feel like I've got something pretty good going, but I also think it might could still use a little bit of tweaking. So yeah, let me know any of your thoughts. Also, just feel free to reach out and say hi. If you have any questions regarding Python, I'm available to help anybody who needs it. And yeah, look forward to hearing from you, and y'all have a good rest of your day. Cool. Bye-bye.